What's up, everybody? Welcome to the second part of this review. We have our reviews. We're gonna do parametric equations, inverses, and I think that's it. Inverses, and then some practice problems, right? So we have parametric equations. We have it's basically two things can depend on a variable, right? So instead of one depending on the other, two things depend on one. So it's kind of like z equals x squared plus y squared, but it's not really, because, well, we have x squared. Let's say t is equal to x squared, and then we have y is equal to 3t plus 8, right? So let's say this is the equation, right? So now we have when t is equal to 1, what's x? Well, when t is equal to 1, x is equal to plus or minus 1, and y is equal to 11. When t is equal to 2, what's x? X is equal to plus or minus square root of 2, and y is equal to 14, right? So you can graph this. You can graph this like this. We have 1, 11. Let's say, okay, when t is equal to 0, this t equals 2, and then when t is equal to 0, well, x is just 0, and then y is going to be 8, right? So we have 0, 8, and then it just goes 0, 8, and then plus or minus 1, plus or minus 1, 11, plus or minus square root of 2, 14. So it's gonna go up like this, right? And like this if the 8 is applicable. And this makes sense because when you put t equals x squared into this equation, you'll get y is equal to 3x squared plus 8, right? Let's do another one. We're gonna try to find the explicit equation for y is equal to x squared. So for y is equal to t squared plus 2t, and then x is equal to 3t plus 5, right? So how are we going to find the explicit equation? We need t in terms of itself. So if you want to get t in terms of itself, there's a few ways to do it. You can use the y, you can use the x. I'm going to use the x because it's a lot simpler. We can subtract 5 and divide by 3 to get x minus 5 over 3 is equal to t, right? And then just plug the x minus 5 over 3 into here. We'll have x minus 5 over 3. I apologize for the extremely messy equation, but right? And then now this will get you x minus 5 squared, which I'm not going to expand, over 9 plus 2 times x minus 5 over 3. And 2 times x minus 5, 2 over 3 is the same thing as 6 over 9. So this is also equal to 6 over 9, right? 6 times whatever this is over 9. So we have that's equal to x minus 5 squared plus 6 times x minus 5 over 9. And that's the correct answer. That's the simplified answer, right? So that's parametric equations for you. Okay, I'm really sorry about that. Anyways, today we will next we will figure out inverses and horizontal line tests. So inverse, what's an inverse? Well, the inverse is kind of like the opposite of a function. So we want an inverse so that when you have f of x, and then the inverse is f of negative 1 of x, so f inverse of x, right? You'll have f of inverse of x, f of f inverse of x is equal to f inverse of f of x is equal to x. That's what you want, right? So we'll do some simple examples. Let's do y is equal to 3x plus 5, right? So your inverse is x equals 3y So your inverse, if you want to get your inverse, you switch the x and y together. So you'll have x equals 3y plus 5, and then you want the y again. So subtract 5, divide by 3, y is equal to x minus 5 over 3, and let's verify if it's correct. We have f of f inverse of x, or y of y inverse, whatever, which will give you 3 times x minus 5 over 3 plus 5. Cross those, your answer is correct. What about f inverse of f of x? Well, f inverse of f of x is equal to 3x minus 5 plus 5 over 3. Cross those and cross those. Correct. Right? It's really satisfying, right? F inverse of x is equal to x is equal to f inverse of f of x. So, what's the horizontal line test for? Well, sometimes, not most of the time, sometimes whenever you find inverses, they don't become a function anymore, right? For example, y equals x squared. Horizontal line test dictates that when you do this, it can't hit, it can't hit all of the points, right? One line will hit 2 points. So okay, the easy way to think about it is the easy way that I want to think about it is like the fan test, right? So if you have this fan right here, if you have this fan, okay, that's a terrible fan. If you have this fan and it's blowing wind, the parts that are not getting affected by the wind, if everything gets affected by the wind, then good. It's an inverse, right? It's a function when it's an inverse. If not everything gets infected by the wind, then it's not an inverse. No, it is an inverse, but it's not a function when it's an inverse, right? So for example, okay, we have cosine, right? Cosine of x. Nope, that looks like sine. Cosine of x, right? This is cosine of x. If you put the horizontal line test through it, it hits a bunch of things, right? It's not even the limit to infinity isn't even defined. So we don't even know how much of the graph the fan actually hits. Therefore, it's definitely not a function. But it is a function when it's like this, right? However, we have some functions that are functions when they are like for example this function. We have some functions that no, not like that. We have some functions that are functions. We have some functions that are functions when they yeah, we have some okay, I'm pretty sorry. We have some functions that are functions when they are flipped. No, when they are flipped, but not functions when they are like in a straight line, like this, right? Like this. See, not function. They're not a function because when you put a straight line through it, they're not a function. But when you put a horizontal line through it, it is a function. This is a function when it's an inverse, but it's not a function when it's not an inverse. And finally, the final thing about functions is whenever you have one of these, right, and then you have a graph, just a random graph, maybe like this or something, right? The inverse is a reflection of the function on the y over x axis, right? So if you this is a random function, I don't know the equation of this function, but I do know the inverse looks something like this. There you go. I should make that blue. Okay, actually control Y, and then I'll make that orange. There you go. So that's the inverse of the function, right? That's f negative, and oh god, no. Next. So we want to find the inverses of these functions, right? These are a little harder. So f inverse of x is equal to, what is it equal to? Well, we set y, so we have x is equal to y minus 7 over y minus 2. We multiply y minus 2 on both sides, we'll have x times y minus 2 is equal to y minus 7. right? We multiply it out. Xy minus 2x is equal to y minus 7. We switch the y and the 2x. We'll have xy minus y is equal to 2x minus 7. We factor out the y. We'll have y times x minus 1 is equal to 2x minus 7. And then we have y is equal to 2x minus 7 over x minus 1. Let's verify if it's correct. This is going to require a lot of algebra, so bear with me. So we'll just do one of them. So f of f inverse of x. Right? Caution. Actually, no. We have f of f inverse of x right here. So we will do f inverse of x is this. So we have 2x minus 7 over x minus 1 minus 7 over 2x minus 7 over x minus 1 minus 2. Okay, so in order to verify this, we need to put them all under x minus 1. Or this is what we can just do. This is literally what we can do, right? This is x minus 1 in it. This doesn't have x minus 1 in it. We can divide it. We can multiply everything by x minus 1. Multiply this whole thing by x minus 1, right? We multiply this whole thing by x minus 1, right? So now this, when you multiply to this removes this, but this gets an extra x minus 1, right? So this removes this x minus 1. This gets an extra x minus 1. Now you have 2x minus 7 times 2x minus 1 over 2x minus 7 minus 2 times 2x minus 1. And this will give you 2x minus 7 minus 7 times 2x minus, this will give you minus 12x, I think. Minus 7 plus 7, that's just, wait, I might have done this wrong. Wait, 2x minus 4, that's just 2x. And then, yeah, I probably did this wrong. Wait, let me see. X equals y minus xy, y minus 2, xy minus 2x, xy minus y equals 2x, y times x plus x minus 1 equals 2x, x minus 2x minus 7, x minus 1. 2x minus 7 multiplied by x minus 1, you will have minus 7 times. Okay, I don't know where I got my 2x from. It was just supposed to be a regular x minus 1. Okay, there you go. So what you will get is, I think this is still the wrong answer. Plus 7 minus 7, that's minus 5x over 2x minus 7 minus 2 times x minus 1. So 2x minus 2x is nothing. And then minus 2 times minus 1 is plus 7 plus 1 plus, that's just 5, which is just minus. Oh, wait. No. Minus 7 times 1 times minus 7x. So this is minus 5, which will give you x. And that's the correct answer. Okay. I was a little scared for a second. So, what about function of this? Inverse of this. I mean, inverse. F of x equal to cube root of x plus 3. So, we'll have x is equal to cube root of y plus 3. Really simple. Cube both sides. X cubed equals y plus 3. And then y is equal to x cubed minus 3. And that's the answer. Right? You can plug that in. It's easy. You can do in your head. You don't have to do any of this junk to verify. Right? But are they functions? Well, this one is a function. This one is a function, because whenever you do this is the cube root of x, right? So you can do this and boom. See, that's the cube root of x. I don't think the cube root of x is in the basic function. And then you can do this, and then you'll have a function, right? Because it passes the horizontal line test as well. So we'll do some questions from the book. We're gonna get to question 68 on the chapter review, which is, I'm flipping the book right now. You should flip the book with me as well. Inscribing a rectangle under a parabola. And a rectangle inscribed in between the x-axis and parabola is 36 minus x squared, with one side along the x-axis as shown in the figure below. So we have kind of like this, and then we have a square or a rectangle, and we have the x-axis, and then we have the y-axis, right? Something like that. But this is actually on the axis and not badly drawn like this. There you go. So the question is, let x denote the x-coordinate of the point highlighted in the figure. So like right here, right? That's x. Write down the area of a rectangle as a function of x. So so this is x, right? What is this? This is if this is x, this has to be negative x, because the parabola is symmetrical, right? And it's symmetrical, and this is y equals 36 minus x squared. So the line of symmetry is in the zero. It's in it's not in, it's at y equals 0, right? That's where the line of symmetry is. This is negative x, this is x, so the length of this total is 2x. And then if this is x, this is just going to be the 36 minus x squared, right? So the total area is 2x times 36 minus x squared. Which values of x are in the domain of A? So you have to kind of be a little bit intelligent, because, okay, this is 36 minus x squared, so we want to set that equal to 0, right? I'm going to set this equal to 0, which will give you plus 36. Now, this is just 6 minus x times 6 plus x is equal to 0, which is, well, x is equal to 6 and negative 6. So this is we have this right here is x is negative 6, and this right here is 6, right? 6. That's negative 6, that's 6. Let's color code it. Negative 6, 6. So the domain of x can't actually be any higher than negative 6 to 6, right? But the domain, this domain of x. No, not domain of x, domain of A. This domain of A, actually isn't even negative 6 to 6. It's actually just 0 to 6, because you can't have negative area. That does not make sense, right? Actually, you could have negative area, but it really just doesn't make sense, right? So domain can either be negative 6 to 6, or just 0 to 6. I think open bracket on 0 would make more sense. So this will give you minus x to the third power, plus 72x, right? Which I actually don't know the graph of. I can try to figure it out, but it will take too long probably. It's just minus x times x squared plus 72, or 72 minus x squared times x. 72 minus x squared times x, which is, well, x is going to be square root of 72 and negative square root of 72. So it'll look something like, since it's minus x squared inside, that means it has the higher power, so it'll be bottom to top. So it'll look something like this. It'll look something. No, there won't be an arrow, because it'll look something like this. There you go. Right, and because it's 36 minus x squared, it will be actually, wait, this is the wrong graph. It'll look something like this. There you go. So this is the correct graph. we have a maximum somewhere here, and this maximum is where we want our box to be. Use your grapher to find the maximum area of what the rectangle could have. We don't have to use the grapher. We can actually work it out ourselves. So the answer is, oh no, we have 2x times 36 minus x squared. It's increasing. It increases for a really kind of long time. We have 36. Actually, no, we do need to use a grapher. But I can tell you right now that the maximum of the function is going to be at. Let me do some calculations. The maximum function is going to be at plus 3. The maximum function is going to be at 3, right? So 3 is our optimum square. We have optimal square. 3 times 2 is 6, and 3 squared is 9. So 36 minus 9 is 27, times 6 will give you 162 units squared, and that's our square. That's our best square. So that's the problem. Yeah, that's my thinking through the problem. It's probably a bad way to think, but whatever. Problem 33. A square of sides x inches is cut out of each corner of a. This is 1.6, by the way. This is not the review anymore. So we have a 10 by 18. That's a 10 and that's an 18, right? We have corners, squares of sides x, right? And then and the sides are folded to form an open. Okay, so we have x right here, we have x right here, we have x, 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 right? And then we have a square of side pieces. Side x inches is cut out of each corner of a 10 by 18. So this whole thing is 10, this whole thing is 18. So the function is, if you want like the height, I'm gonna draw this cardboard box right here. Right here. There you go. So this is 10, this is 18, and this is x, right? Well, no. This whole thing with the x is 10. So this whole thing is 10. But that itself isn't just 10. So this we have to find this section, and we have to find this section, which is corresponds to this section and this section. So this section is just 10 minus 2x. 10 minus 2x. This section is 18 minus 2x. Right? Obvious enough, hopefully. 10 minus 2x and 18 minus 2x. And the maximum, the function will be x times 10 minus 2x times 18 minus 2x. And that is our question. And B, find the domain of the function. So what's the domain of the function? Well, if you think about it, we're doing the relevant domain, right? So this box has 10 by 18 sides. If you cut any more than a certain amount, the box won't be a box anymore. It'll just kind of be like negative area, kind of like poof, right? It doesn't work when you cut more than this amount. And what's this amount? Well, this amount is halfway through the length, which is 5, right? So the domain is between 0 to 5 inclusive, 0 to 5 exclusive, because you can't cut 5 or else it really wouldn't make sense, right? So C is just figure out the maximum, right? And I'm gonna figure out the maximum. I'm gonna help you figure out the maximum. It's x 10 minus 2x, 18 minus 2x. So we can just I'm not gonna help. I'm gonna figure it out, right? You can see me figure it out. It's probably not fun though. We'll have 4x to the third power, minus 36 minus 56x, plus 180, x squared plus 180x, and then we can do some magic to get 12x squared minus 112x plus 180 is equal to 0. we will want to set this equal to that's 9 1/3 x plus 15 is equal to 0. And I don't want to work this out. I definitely don't want to work this out. Yeah, I don't want to work this out. I'll just use a grapher. I'll use a grapher. Desmos. So we have ourselves x times 10 minus 2x times 18 minus 2x. And our relevant domain is between 0 to 5. That's our relevant domain. And our maximum is achieved at x equals 2.063. And our maximum is at 2.063, 168.136, and that's why I didn't want it to do. I didn't want it to do the problem. That's it for that problem. Okay, final problem is a mixture problem. If you need help from the mixture problem. So question 32 is the chemistry lab at the University of Hardwoods keep 2 acid solutions in hand. One is 20% acid, 0.2 acid, and the other one is 0.35 acid, right? And hardwood keeps and how much? 20% acid and 35% acid do we need to prepare 25 liters of acid solution? So I'm gonna work this out in the x and y way. You can work this out in x and whatever minus x, but I'm gonna work this out as this is x and this is y, right? So 0.2x plus 0.35y, or 0.2x plus 0.35y is equal to the 26% acid solution, so 26% acid, but it's 25 liters of it, right? So how many liters of x times the 20% plus how many liters of y times the 35% equals how many the 25 liters times the 26%. And then we have the amount of x and y liters have to equal to 25, right? So those are our two equations. So what's 0.26 times 25? That's 6.5, right? And then now we have the two equations. We can multiply this whole equation, this 0.2x times 0.35y equals by 5. So now we'll get, well, this new equation will have x plus 1.75y is equal to 5 times 6.5 is 32.5. Subtract. We're going to subtract these two equations. We'll get x minus x is 0, y minus 1.75y is minus 0.75y is equal to minus 7.5. You can put that in a calculator, you'll get y equals 10. Y is equal to 10. So now we have x plus y is equal to x plus 10 is equal to 25, so x is just equal to 15. So we'll need 15 liters of 20% acid and 10 liters of 35% acid to make the 26% acid, right? That's gonna be it for today's video. If you have any questions, just ask me. I know the test is tomorrow, and you probably won't have enough time to watch this whole video. Probably don't have enough time to look at your notes even, because it's 20 questions long. It's a long test, right? It's 2.5 times longer than the quiz. So good luck on that, and I'll see you next time.